So, my name is Riak Solr. Today I'm going to speak about Elasticsearch. This is index server, and I'll try to answer the question if the Elasticsearch can be used as a Docker database. So, first, a short story about me. I'm living in software for about 70 years. I'm a freelancer. More information you can find on LinkedIn. So, Elasticsearch, what is it about? It is a search server based on Apache Lucene, so the same engine as Solr is based on. It is a distributed system, so from the start it was designed to be distributed. It is multi-tenant capable, what is very nice for cloud systems. It has full text search capabilities. It has RESTful web interface. It has schema-free JSON documents. It stores all documents as a schema-free as a JSON documents, and therefore it has also a lot of NoSQL capabilities. So first release was Elasticsearch was released for the first time in February 2010, so it is only 4.5 years old. And until now, it raised total funding of more than $100 million. Latest release are 1.3, this is stable, and 1.4, this is beta. The producer or company that stands behind the Elasticsearch also provides ELK stack. This includes Logstash and Kibana. These two are, as I know, they are commercial products. And it is open source. It has liberal Apache open source license. You can find the sources on GitHub, and it is very popular. It is used by very famous companies, starting from Wikimedia, Mozilla, Stack Exchange, Quora, Cloud, GitHub, and so on. They also provide professional services, what is also very nice to have for very serious companies. But when you click on the links, you get 404. But okay, this is my small digression. The docs I found good, not excellent, but good enough for learning Elasticsearch. This could be a good start, but for getting into details, you need to search and buy a book, search on over the internet, ask questions and find questions on Stack Overflow and so on. Features. Feature sets I split into two parts, system features and development features. System features I already mentioned them. What is also good is this high availability, this design from the start to be multi-tenancy. And from development, when I was choosing Elasticsearch for the project I worked on, and I am still working, I was especially interested in these marked features. RESTful API document. It was a document oriented. It was schemaless, and it has full text search capabilities. So installing and running is quite simple. You need to have a JDK, so it is Lucene based. You download it, you unzip it, and you run it. So this is so simple. And you can use it. So just normal ping, this is default port 9200. You get result. So you have here version number that is running on, and Lucene version number, and why it is used for, for search. So creating and putting some data into the system is quite easy. It is RESTful. You need to specify your HTTP method. In this case, this is put. You define an index and you define doc type. So index is some kind of database, and doc type is some kind of table in relational databases. So and you define the ID. So this document is here is important to note that besides normal attributes, which can be string, dates, and integers and floats, you can define a complex object like array, and you can define nested objects, which can also have another nested object, and so on. So in this case, this is very interesting for me because I have such need. And all of these fields are searchable, and you can do various stuff with all attributes. It behaves as a standard key-value database, so just fetching by the key and by the ID in this case, you can get the same document back. You can notice here that when you get back, you get also index name, so the database name I would say, and the document type. Document type is ls, like a table in database. And you can search. So this is why it was invented for. So you just specify, this is a simple case of search, you just specify, for example, just a query, or you can find by some field. So this field is nested, so you find the values inside of the document. So you get results back, you get one record back, and you get scoring, so it sorts by relevance by default. And you get documents back. So what is the database? So I found on Wikipedia and I tried them. There are some kind of structured or organized collection of data. But the more important question is what is RDBMS? So database management system is the system that provides interface between users and databases. So there are 4 types of interactions. So data definition update, that means create, update, and delete, and retrieval, that is read from Crud, and administration interactions. So is Elasticsearch a database? So when you check item by item, then we see that all these criteria are fulfilled, and we can say that Elasticsearch is really a database. So what kind of database? I would say, not I would say, it is document-oriented database. This is some kind of NoSQL branch, they call it, but it is not really. It is I would not agree to this. But what is document? I would not try to spend too much time, but document is something like I just posted into the server a few slides before. So the same situation, the same document, if it is represented in a relational database, it would be represented in 5 tables, normalized, and it would consist 9 records. So for some cases, this is better way to do it, but for some reason it is not. So regarding data definition type of interactions, so Elasticsearch is schemaless, but it provides you can define schema. They call it in Elasticsearch mappings. In mappings, you can define various things. All of these things relate to the search setup. So you can define various data types, if it is string, integer, float, and so on, and you can define complex data types like array, or object, or nested, or geographical data, or even attachments. And search analyzers and boostings and the plethora of other options you can define on the mappings or sometimes in query, when querying system. When compared to relational databases, we lose some things. What is very often happens when you deal with NoSQL systems. You lose data validation, you lose integrity checks. You remove normalization, you do denormalization, so you do redundancy. In my opinion, relational databases are much fine-grained, structured than NoSQLs. And what is also important, SQL is standard and common way to deal with databases, and relational databases are very popular and a lot of people are very familiar with. So this is also what you need to think about when choosing such a solution. So retrieval or getting databases, we have this example before. The same thing when written in SQL, you get much more complex query, but I would not stop on this. So Elasticsearch or they provide query DSL, so some special type of DSL just for query. So based on my experience, I would rather use Elasticsearch for searches, what is invented for, especially for fuzzy search, and you can search for, between a lot of fields. For example, not only one field. You can search with a lot of documents, and you can search also within multiple indexes. So you can search one search, could try to hit everything that is consistent in the whole system. When you do development, it is easier to deal with JSONs than with ORM objects or raw SQL results. You get plain object only data, and you can it is easier to deal with. And what is especially important when doing single web applications. And on the other hand, with SQL or relational databases, it is, in my opinion, I would use rather SQL when composing complex queries, complex structured queries, I would say, and also for data exploration, researching, and so on. This is all related to Retrieval. I will later touch also update. So I would say that in general, SQL is much more expressive domain DSL than it is Elasticsearch query DSL. So when you do things in Elasticsearch, you need to join somehow these subdocuments, sub-objects, and you need to do denormalization. But it's, in general, it increases retrieval performance, which is very nice. But it uses much more space, and also making hard to keep things up to date. This is also something that is main part of the job when you deal with such systems. But on the other hand, they are excellent for write once and read many workloads. So if you have such system that needs to deal much more with reading than with writing, then this is good, possibly good solution. So joining options, Elasticsearch can have 4 types of joining. You can embed the document directly this is sub-object. You can embed directly sub-objects into another object. This is the same. This is the example that I showed before. Nested objects are the same thing, but you note this somehow in the mappings, in the data definition, and in this case, this enables you to do some more complex queries. And you can define for example, two different type of documents and join them together somehow with parent-child relations established between them, and which also then enables you to do some complex queries between 2 document types. And you can compose manual queries, for example, collecting all IDs and then compose another query that fetches these related documents. So for reading, this is very handy, this first and second option, and also third is also a good one. But for querying, it's not so handy. Updating, this is create, update, delete part of the analysis. So I would rather use Elasticsearch when I deal with single nested documents. So not, on the other hand, I would use rather relational databases for flat entities and documents, for mass objects manipulation, for example, a lot of changing a lot of records in the database. When you need to deal with transactions and integrity, this is something that relational databases provides. But on the other hand, the Elasticsearch and similar system and no SQL does not. And also, what I said, I found SQL more expressive. For regarding administration, so installing, configuring, maintenance, monitoring, scaling, I'm not DevOps or administrator, but from my point of view, I need to deal with it from time to time. I found it quite satisfying. All major operating system somehow enables integrated installation of Elasticsearch, whether it is apt-get, Yum, or Zipper, or Brew on OS 10. And plugin installations is also quite easy, so you can go just directly to the directory and then start plugin, install plugin. You have various GUI systems. First one is Marvel. This is provided by the company that provides also Elasticsearch. It is commercial options, but you have also quite good and maybe in some cases better options that are open source, whether it is GUI or console libraries. So, using Elasticsearch as a database, this is not something that I have invented. This is something that a lot of people try to establish, and you need to ask some other questions also. I only touched several. So, what about hybrid solution? So, Elasticsearch plus something else. In this case, can you use Elasticsearch as a single point of truth, so spot? You could, but it could. You could use it other way around. You could use another database for constraints, correctness, and integrity, and transactional updatable system, where the master record will be retained, and then asynchronously push-pull to Elasticsearch. So this is some general scheme on the project I have worked on. So you have request from web server. If it is read, then you go directly to Elasticsearch, and if it is write, you go to relational databases where the data is changed, and then synchronize asynchronously to Elasticsearch back. This is also important to mention. Elasticsearch provides reverse. This is some kind of alternative way for inserting data into Elasticsearch. And you have a lot of already ready to use reverse to integrate with another systems, whether it is relational databases or NoSQL databases or something else. So this was my use case, and these are my observations. Indexing and re-indexing sub-documents is a major job. This is something that I spent a lot of time. Abstract mode is also something that you need to know. This is update, and if not found, then insert. So this is also supported by indexing search. Issues, I have several issues, starting from not indexing well memory. It was memory hungry. I got out of memory exceptions and things like this. Full reindex, you need to do full reindex sometimes, and when you build abstract syntax, when you build the queries, you need to think another way. Somehow you need to think if you are building abstract syntax tree, so this is different kind of thinking. But I'm quite satisfied with the final result. And this is something that I also wanted to note, that this is not the only way, I'm not the only person who tried to do this. This is some trend. So a lot of other systems try to integrate several search engines with their database system. Starting from Riak, they published it from last month that they integrated Solr, which is running a separate airline application, and asynchronously synchronized data. Couchbase has also on their page some plugin for Elasticsearch. MongoDB, so they don't have good free text search, so they try to integrate Elasticsearch, not they, but some company compose. This is just an example. And this is also good old school. So Postgres full text search is good enough. For some cases, I find it correct. So Elasticsearch, I would suggest to use when you need very good, reliable, handy, web-oriented search index engine. This is first purpose. And if you have intensive read and document-oriented application, this is also a good solution to check what is more appropriate. So in summary, I think this is my conclusion. There is no silver bullet. You need to choose the right tool for the job. You need to learn and get familiar with different solutions and choose the optimal one to be objective and productive. And this is a general trend that systems are getting more and more heterogeneous, which means that we need to deal with more and more integration tasks. And don't forget to learn new things and have fun. So this is the end.